Okay, so this is fourth experiment, which is a coefficient of friction. So aim of the experiment is to determine the coefficient of friction for given contact surfaces. So this coefficient of friction is static coefficient of friction. So this is the schematic diagram for your experimental apparatus. So it consists one inclined surface, then there is one box. So this is the wooden box. So in this wooden box, we can add the known weight. Okay, so this may be 50 gram, 100 gram. And the wooden box, it will have its own weight. Then it is connected to another block. So this is actually a pan. Okay, so in this pan, we can add the required weight. And this string is passing over this smooth pulley. So when we say it is a smooth pulley, we neglect the friction between the string and the pulley. So we can assume this as a frictionless. Okay, now to find out, our aim is we have to find out the coefficient of static friction between two contact surfaces. That means the surface of this wooden box and this horizontal surface, that is the inclined plane. So for that, we have connected one pan with the help of this string which is passing over this pulley. We will add the weight in this pan gradually. Okay, suppose we will add initially 10 gram, 20 gram, 30 gram, so on. At a particular weight, this box, it will be on the verge of motion in the upward direction. So we have to find out that limiting condition. Okay, verge of motion means what? Suppose we add 50 gram in this pan. Okay, at 50 gram, the object or this box, it is on the verge of motion. Means if you add more weight, suppose we add 55 gram, then box will immediately start its motion. So it will be in the dynamic state. So this is the limiting condition or the limiting force for which the object will be in the equilibrium state. And for the limiting condition, the friction force, it will be the maximum friction. So this is the Fmax, or this is called as a limiting frictional force. And this frictional force, it will be equal to mu s into the normal reaction. So we have to reach this limiting condition, that is the Fmax value. Okay, so we have to find out this weight in the pan for which the object or the box will be on the verge of motion. Okay, so during the experiment, you will connect this pan. Okay, and in this pan, you will add the weight gradually from 10, 20, 30 gram. Okay, and you will find out one value for which the object will be on the verge of motion. Okay, so this weight in the pan, it will create the pull force, which is the P. So it is the same force. So we will consider this total force as a P. So its direction will be like this. Okay, same force will be transmitted on the other side of the pulley as the pulley is frictionless. So this is the P force. So P force, it will act at this point. Okay, so now we will see how to find out the coefficient of friction. So for that, we need to draw the free body diagram. So we will draw the free body diagram only for this box. So this box, it is resting on this inclined plane. So this angle of inclination with respect to ground, this is theta. Now the self weight and this weight, so the total weight we will consider as a W. Okay, so it is the weight of the wooden box including this added weight. So it will act exactly in the vertical direction. Okay, now when we solve the problem on the inclined surfaces, assume this inclined surface as a x-axis and perpendicular is the y-axis. Now the normal reaction that is provided by this surface on this box, it will be like this. It is exactly perpendicular to the contact surface. So this is your normal reaction. Okay. Now this is the external force P, which is the tension in the string. So this force P is exactly parallel to this inclined plane, or it is along the x direction. Okay. Next is the frictional force. As the impending motion is up the plane, friction force will be like this in the downward direction, and this value is F max, which is equal to mu s into normal reaction. Okay, so this is your complete free body diagram. Now here, just observe this x-axis and the y-axis. So the force which is inclined to this axis, we have to resolve that force. So here, normal reaction is along y-axis. F max and the P, they are along the x-axis. So only this W, it is inclined. So we have to resolve this force. So draw the component parallel to y-axis. Draw the component parallel to x-axis. As this angle is theta, so this angle with respect to y-axis, it will be theta. So we have already seen this when we solve the problem in the friction. So this component is W sine theta, and this component, this is W cos theta. Okay. So now next is we have to write the summation fx and summation f1. So summation fx is equal to 0. So refer x-axis. P force is on the negative side. So this is minus P. F max, which is mu s into n. So it is plus mu s into normal reaction. And the x component of this W, which is W sine theta. So this is plus W sine theta. This is equal to 0. Now use second condition, which is summation fy, this is equal to 0. For summation fy, observe this y-axis. Normal reaction is along positive y direction, so plus n. W cos theta is on the negative y direction, so minus W cos theta, this is equal to 0. So from this we will get n is equal to W cos theta. Put this value in this equation. Okay, so we will get minus P plus mu s W cos theta plus W sin theta, this is equal to 0. Now from this equation, we can write mu s into W cos theta, this is equal to, take this term and the P on the right hand side, so P will become positive and W sin theta is negative. Okay, and from this we need the mu s, that is the coefficient of static friction. So mu s, this is equal to P minus W sin theta upon W cos theta. So by using this relation, we can find out the coefficient of friction. for the given two contact surfaces. So this is your formula to find out the coefficient of friction. Okay, so here P value, it is nothing but the weight added in this pan. W is nothing but the total weight of the box, including the added weight. And theta is the angle of inclination for this surface. So during the experiment, we have to measure this angle for the inclined surface. We have to note down the value of weight in the pan and weight in the box. So we will refer this formula and then you can find out the coefficient of friction for given two contact surfaces. Okay, so now let us see how to perform the experiment. So first, note down this calculation. You can take the screenshot. So you have to write this calculation for mu s in your experimental writer. You have to draw this free body diagram. Okay, just take this screenshot. So I'm going to erase this. Okay, so observe the procedure for the experiment. You will have this complete setup, this pan connected, then the box. You will add certain weight. So just imagine we have added the 10 gram weight or 20 gram weight in the box. Now we want this box to be on the verge of motion. Okay, verge of motion means what? It will just slide in the upward direction. This is called as a verge of motion. So we will add the weight in the pan gradually. So initially we will add 10 gram, 20 gram, 30 gram. So in this way we will go on adding the weight in the pan. So at a particular weight, you can observe this slight movement for this box. Okay, it is not completely in the dynamic state, but you can observe some movement in this box. So it will be on the verge of motion. Okay, so this movement is nothing but the verge of motion. It is not completely moving. So this is the verge of motion or the impending motion. So for this condition, the friction force, it will be the maximum frictional force or it is a limiting frictional force. And beyond this, if you add more weight, then you can see the complete motion. So that is the dynamic state. So this weight, it is nothing but the P value in that formula. Okay, P minus W sine theta upon W cos theta. So again observe. For this weight, okay, so this is the verge of motion condition. And after this, if you add the weight, so this is the complete motion. Okay, so we need to find out that limiting condition. So we have to find out this weight. So if you add more weight, then you can see the complete dynamic state. So let us see how to perform this on the physical setup. So here, this is the physical setup. This is inclined surface. So it is the acrylic surface, and this is the wooden box. So in the experiment, you can directly measure the angle by using this protractor. So it is already given with the setup. So initially, so for the first reading, we have taken this angle of inclination as a 20°. Okay, we can change this when we are repeating the experiment. So contact surfaces are wooden surface and the acrylic surface. Now this is the string connected. This string is passing over the pulley, and one pan is connected so that we can add the weight. Now here in the pan, we will add the weight gradually so that this box will be on the verge of motion. Verge of motion means what? We can just observe the slight movement for the box. And beyond this, if you add the more weight, then the block will be in the complete motion. That is the dynamic state. So we have to find out that limiting condition, because at that condition only friction force will be the maximum frictional force, which is the Fmax value. And Fmax is equal to mu s into normal reaction. So this weight of the box, it is 81 grams. So it is written on the box. That is the self weight of that wooden box. And we have added 20 gram in this box. So total weight here, that is a W in your calculation. So W is equal to 101 gram, 81 plus 20. So this is the weight added in the box, which is equal to 20 gram. Okay, so now we will start adding the weight. So initially we will add very small weight and just we will observe the motion. So there is no motion, so it is in the equilibrium. So gradually increase the weight. So you can give little jerk to this surface so that we can observe the impending motion. Okay, so this is the impending motion. So again observe. So at this condition, you can observe the slight movement of the box. It is not completely moving. Okay, so that means the block, it has reached to the limiting condition for the equilibrium, and it is the Fmax value for the frictional force. So this is called as a verge of motion. Again observe. So there is a slight movement, which is the verge of motion condition. For this condition, friction will be the maximum. So here you can note down the total weight in the pan. So that value will be the force P. Okay. So in the formula, P minus W sine theta, W is this total weight. including the weight added. Okay, so P minus W sine theta upon cos theta, and theta is the angle of inclination. So this is your experimental procedure to find out the coefficient of friction. For second reading, you can change the angle, you can change the weight in the pan, weight in the box. Okay, so W will change and theta will change, and similarly you can repeat the experiment. So I hope this procedure is clear. Okay, so this is your observation table. So in the observation table, so this is the serial number. Then first column, so it is the weight added in the box. Okay, so this weight, you can take this in kg. Then total weight of the box. So total weight will be the self weight of the box. So it was 81 gram. So this is equal to 0.081 kg. The next is weight in the pan. So weight in the pan. So you can take this in kg or in terms of gram. Then total weight in the pan. So total weight means we have to consider the self weight of the pan. So this pan, it is having self weight. So self weight of the pan. So this is equal to so this is 40 gram. So this is 0.04 kg. The next column, it is the coefficient of friction, which is the mu. Okay, so total weight in the pan is nothing but the P value. Okay, so this is P minus W sine theta upon W cos theta. Okay, so during the experiment, we have fixed the angle theta. Okay, so theta was constant. So theta, it was 20 degree. And then you can repeat the experiment. So we have just taken 2 readings. So this experiment, initially it was conducted for the contact surfaces, which is a wood and the acrylic. And after that, we changed the surface and it was a glass and the paper. Okay, so for the second reading, where glass and paper angle was same, it was 20 degree. Okay, so in the observation table, weight added in the box. So in this box, we have added the weight. So initially it is 0. The total weight, it was 81, as it is a 0 kg. So it is not 81 kg. Okay. So this total weight is nothing but the W value. Then weight in the pan. So this is 0.09. So it is a 90 gram. So total weight, it is a 90 plus 40. So it is a 130. So it is 0.13 kg. And then find out this mu. Okay. P minus W sin theta upon W cos theta. For second reading, we have added 50 gram in this box. So this is 0.050. Total weight, it is a 50 plus 81. So this is 131. So it is 0.131 kg. Then weight in the pan. So this is 124.124 kg. So total weight will be this 0.124 plus 81. Sorry, plus 40. So this is 164. It is 0.164. And find out this value. Okay, so try to complete this calculation for the given readings. For the second observation, theta was 20 and the surface was glass and the paper. Okay, that means the box, this wooden box, we have covered this wooden box with the paper, and this surface we have replaced by the glass. So the first reading, this is 0, this is 81, so it is 0.081. Then weight in the pan, so this is 40 grams, so it is a 0.04 kg. Total weight 40 plus 40, it is 80. So this is 0.08. So this is the P value and this is the W value. So calculate the mu value. For second reading, in the wooden box, we added 50 gram. So it is 0.050. So total will be, sorry, we added 10 gram. So this will be 0.091. Okay, so 91 gram. Then force, weight in the pan, we added 51. So this is 0.051.